Hello, dear students. I am Professor Abu Tariq and I will be teaching the course Electrical Drives in this semester. The course number of this course is EEC 3110. First, let me explain the meaning of these symbols here. The first two letters here, EE, means it is the course offered by Department of Electrical Engineering. Then C means it is the departmental core category course. So the course category is departmental core. That is, it is compulsory course for each electrical engineering student. It is a 4 credit course. This means that you will have 4 periods per week for this course. Now, before we start the syllabus and we start serious discussion on the various topics here, let me first define what drives actually means. So, drives is systems employed for motion control of certain load. Motion control is a common term. It includes position control and speed control. Position control means you have to move some object from one position to other position. And speed control means that you have to move the load at various speeds. Take for example the case of a lift. You have to move the lift from ground floor to first floor. So it is a position control from one position to other position. So lift should start from ground floor and should stop at the first floor. So it is position control. And you may also have to move the lift at different speeds. You want to have a control of speed also. So that is speed control. So any system which moves the load from one position to other position at various speeds, we call the system as drive. The drive may use various prime movers. You may have some IC engine. For example, in your vehicle, in your car, we have IC engine there. So it is engine based drive. Or it may have some electric motor. So if the prime mover in the drive is electric motor, then we shall call it an electrical drive. So this is what is electrical drives. The whole system, including the source and the load and the motor and the control mechanism there, it is called electrical drives. Now, what are the various components of electrical drive? Let us try to understand it with the help of this block diagram. You can see that we have a source here, we have a power modulator, we have a motor, the load, sensing unit and the control unit. Let us discuss one by one. The first component shown here is source. Source is the power source. The power source can be AC source or a DC source. In most of the cases, the supply available is AC source. You may have a 400 volt AC supply 3 phase, or you have a single phase AC supply. You may have for higher system or higher large size drives, you may have a higher voltages also. You may have 3.3 kilovolt supply, 6.6 kilovolt supply or 11 kilovolt supply. So in larger systems you will have higher voltages. So usually the supply is 50 Hz AC supply at various voltages. Now the supply may also be a DC supply. Sometimes the power comes from some battery. For example, in the vehicles, electric vehicles, some batteries are used. So that will be a DC source. And the voltage may be 12 volt or 24 volt or 48 volts or 110 volts. So the voltage will vary depending on the size of the drive. You may also get supply from some other energy source. For example, you may have solar photovoltaic panel or some fuel cell. It generates power in DC mode, so that will be DC source. So this is about the source. Now the second component here I will discuss, that is the motor. Motor may be AC motor or a DC motor. If it is AC motor, we will call it AC drive. But DC motor, we shall call it a DC drive. So the motor may be AC or DC. In AC motors, most of the motors are induction motor. So you may have induction motor or you may have synchronous motor also in some special cases. But usually the motor will be induction motor. Nowadays, most of the drives are based on induction motor. You may also have DC motor. DC motor may be DC shunt motor or DC series motor or DC compound motor or any other type of DC motor may be used. In earlier days, some 20-30 years back, most of the drives were DC motor based drives, because the control of speed of DC motor is much easier as compared to control of the speed of induction motor. So earlier the most of the drives were DC motor based drives, but nowadays induction motor is fast replacing DC motor, because induction motor has some advantages over DC motor. The control of induction motor was difficult, but with the advent of polytronics, you can say that the control has become easier. So this means that nowadays control of induction motor has become easier than it was some 10 or 20 years back. So now the induction motor is replacing the DC motor. So nowadays most of the drives will be induction motor based drives, but in some cases you will have DC motor, you will have brushless DC motor, stepper motor, or switched reluctance motor may also be used. Now the component power modulator, as the name suggests, it modulates the power available from the source according to the need of the motor. So it converts energy from one form to other form. For example, if the motor is a DC motor and the supply is AC, the power modulator will convert this AC supply into DC supply. So basically it will have some AC to DC converter or controlled rectifier. On the other hand, the motor is AC, the source is DC, then it will have to convert the DC power to AC power. So it will use some DC to AC converter, that is inverter. So the one function of this is to convert the energy from one form to the other form, and then it will have to control the flow of power from source to motor such that the motor runs at the desired speed. So this power modulator will control the flow of power to achieve the desired result. That is, the motor has to move from one position to other position. Supply will be available at certain time and will stop at certain time, so that the motor stops. So this is the function done by the power modulator. You have to control the speed. For example, you are using a DC motor and suppose the supply is also DC. You are using a DC to DC converter here or some chopper here. The output voltage will depend on duty ratio of the DC to DC converter. So if you have to increase the speed, you have to increase the duty ratio. So this power modulator will increase the duty ratio of the converter so that the voltage increases and the motor's speed increases. So these are the functions, and it may also have to limit the motor and source current to safe value. For example, you are using a DC motor here. During the starting, the current will be very high. So the power modulator will make the necessary changes so that the current does not cross the safe limit. Similarly, during reversing, speed reversal, again the current may shoot up beyond the safe limit of motor as well as the source. So it will make necessary changes during these transients so that the current remains in the safe limit. And finally, it selects the mode of operation. The drive may operate in various modes. It may operate in motoring mode, where the energy flows from source to motor, and it may operate in braking mode or regenerative braking mode, where the energy flows from motor to source. So this power modulator will do the job of making the changes such that the motor operates in the desired mode of operation. So these are the functions done by the power modulator. Now coming to sensing unit. The diagram that I have shown here is a closed loop drive. So you will require to know the actual condition, what is the actual speed, what is the actual current, then only you can control it. So it will require some sensors. For sensing the speed, for example, you may have a tacho generator. Tacho generator will convert the speed signal into a voltage signal. Or you may require to have a current sensor for sensing the current, what current is flowing in the motor. So the sensing unit will convert the voltage, the speed of the motor into a corresponding voltage signal, or the current of the motor into a corresponding voltage signal. So these signals will be given to the control unit. So this is the function of sensing unit. Then the control unit. Now in the control unit we will get two signals, one coming from the motor, actual signals, and the other coming from your side, that is the input command. You want to run the motor at certain speed, so you are giving a command that what speed you want. So it will get a signal input command and one signal coming from this sensing unit, and this control unit will compare these two quantities and generate a signal corresponding to the condition. For example, you want to run the motor at say 1000 rpm. You are given a signal from here, say about 10 volt. 10 volt correspond to say 1000 rpm, and the signal coming from this, which is a voltage signal corresponding to a speed. Suppose the motor speed is 900 rpm and this is generating a 9 volt signal here. So it is 10 volt, it is 9 volt. So control unit will know that the actual speed of the motor is less than the desired speed. So it will generate a signal, actuating signal for this power modulator, so that the motor's speed increase. For example, if it is say DC converter or chopper, it will give a command to this to increase the duty ratio of the chopper. If the duty ratio increases, the voltage will increase here, the motor's speed will increase, and the signal coming out from the sensing unit will increase. And when input command becomes equal to the actual speed, then the changes will stop, and thereafter the motor will run at a constant speed of 1000 rpm. So this is the function done by the control unit. Now you can see here that there are various types of drives depending on the motor used. It can be a DC drive if the motor is DC motor, or it can be an AC drive if the motor used here is AC motor. Accordingly, you will have one unit on DC drive and 2 units on AC drives. As I said earlier, most of the drives are AC motor drives now. So there will be 2 units on AC drives, 1 unit on DC drive. Now here in the syllabus, which has 4 units, the first unit will discuss the fundamentals of electrical drives. In this we shall learn what are the various types of loads. Some loads are constant torque loads, some loads are variable torque loads. At various speeds the torque requirement changes. So what are the different types of load characteristics? Because actually you have to match the characteristic of the motor with the load. So you must know what is the characteristic of the load. So we shall discuss the various load characteristics. Then what is the stability of motor load system? You might have learned in induction motor course that certain region of the characteristic is stable region, certain region is unstable region. So under what condition the system is stable, in what condition the system is unstable. So these we shall discuss in this first unit. Then also the load may be of different types as far as the timings of the loading is concerned. You may have a continuous duty load, that is the load is available continuously for a long period of time, and sometimes the load may come for only a short time. For example, in welding, the load comes only for a short period of time. You are moving a vehicle, the vehicle moves and then stops. You are having a lift that moves from one place to other place and then stops and remain stationary for a certain period of time. So you have different types of loading pattern, and you have to operate the motor such that the motor is fully utilized. A motor which is of 1 kilowatt rating, if it is given 1 kilowatt load continuously, then its temperature rise will be up to the permissible limit. But if the 1 kilowatt load is available only for short interval of time, say only for 1 minute or 2 minutes, then the load is off. Then in that short loading period, the temperature of the motor will not reach its final steady state value. And you can say that the motor is not fully utilized. Its thermal capability is not fully utilized. So we shall see, we can use a motor of lesser power rating. 1 kilowatt load is there, but we can use the motor of a lesser power rating so that the motor's capacity is fully utilized. So we shall discuss all these things. What should be the rating of the motor corresponding to given type of load. So these we shall discuss in this first unit. Second unit will be on DC drives. In this we shall discuss the various types of DC motors. You already studied in your previous courses of earlier semester the DC motor and its characteristics. So we shall have a review of the DC motor, shunt motor, compound motor, series motor, etc. And then we shall discuss the various methods of speed control, that is the voltage control or field control, what are various ways in which you can control the speed of various motors. Then we shall also discuss the electrical braking of DC motor. So these basics will be discussed first, and then we shall go for the two types of control here. One is the rectifier control, supply AC, and you are having a control rectifier here. So how the motor operates, various characteristics we shall discuss in this part of the syllabus. Then we shall discuss the chopper control drive, that is supply is DC, motor is DC, and you are using a chopper here. So chopper control drives, how you can change the speed of the motor, and what are the various characteristics that will govern the operation of the motor. The third unit will be AC drives. In this again we shall discuss the basic characteristics of induction motor, its torque speed characteristic, various equations, torque equation, and then various modes of operation, motoring operation, braking operation, generating operation. Then various methods of braking, electrical braking of motor will be discussed here. That is, we shall discuss the methods of speed control, that is voltage control, frequency control, or pole changing method, or amplitude modulation, and the rotor resistance control. So basic methods of speed control will be discussed in this unit. Then in the fourth and final unit, again it is on AC drives, we shall discuss some advanced techniques of speed control, that is static rotor resistance control, slip power recovery schemes, and then inverter controlled induction motor drive, and we shall also discuss a little about synchronous motor variable frequency drives. So these are the contents of this syllabus. The textbook for this course will be Fundamentals of Electrical Drives by G.K. Dubey. Some topics will be discussed from some other books I will mention from time to time. The syllabus I will upload in your classroom. You can see it. So this is all about this introduction. From the next turn, we shall start the syllabus one by one, point by point. So it is all for today. From the next lecture, we shall be having about 30 minutes of lecturing, followed by about 10 to 15 minutes for the queries. So I will advise you to go through the lecture before joining the class. For example, your class is from 8 to 8:50. Then I will suppose that you have seen my lecture, and I will be available online at say 8:30 or 8:35 for 10 to 15 minutes. You can ask your questions regarding your previous lecture. So this is all about today's lecture. Thank you very much.